In lesson 5-9, we're going to work on line plots. You will need your whiteboard and whiteboard marker. We will not be using our math journal for this. The lesson that we typically would do is measuring heads for hats. And since we don't have tape measures and we don't have a class full of data, we're going to do this a little bit different today. So you won't need your math journal during the lesson portion of this. Let's go ahead, though, and start with some mental warm-ups. You're going to take the fractions and add them. So go ahead on your whiteboard, and you don't have to write down the problem. Just go ahead and write down the solution to each addition problem. Pause your video and write the solutions. Number 1, remember we keep the denominator the same and add the numerators. So 2 plus 1 is 3, 3/4. Number 2, we keep fifths the same. 2 plus 2 is 4. And 4/6 plus 3/6 gives us 7/6, which we call an improper fraction. You can also change it to a mixed number, and that would equal 1 and 1/6. Go ahead and erase number 1, 2, and 3 on your whiteboard. Remember, we keep the denominator 12ths, 8ths. Oh, and now look at what they threw in on us. We have denominators that are different. Did you notice that? So let me give you a little clue. We know how to find equivalent fractions. So you can change that fraction of 1/2 into 4ths and then be able to add it. So now that you've recognized it, go ahead and solve these 3 equations. Pause your video. Go ahead and add 4 plus 5 is 9. 9 plus 7 is 16. Again, that is an improper fraction. We can leave it at that. We're not really working on being able to, at this point in time yet, to be able to change that to a mixed number. But I know that 12/12 would equal 1 whole, and then I would have 4/12 left over. 5 plus 5 is 10. Same thing, the numerator is larger than the denominator. It's greater than 1 whole. So I'm just going to show you that it would be also equivalent to 1 and 2/8. And lastly, I can change 1/2 into 2/4 and then add 2/4 plus 1/4 to give me 3/4. Go ahead and erase. What we are going to do now is to create a line plot. It says the tables below show children that signed up for summer soccer camp. Campers will be divided into 2 separate groups, boys and girls. What we are going to do is go ahead and solve, and we could do one or the other or both, but for the sake of time, let's go ahead and start with the boys. If we have time, depending on how long it takes, we can do the girls as well. So to make a line plot, you're going to draw a line straight across on your whiteboard. We're going to find the smallest number. The youngest age looks like it is 8. So let's go ahead and put 8 here. And then the oldest student, I see Noah, who's 12. So our line plot needs to go from 8 to 12 to include all the ages. So let's go ahead and make this 9, 10, 11, and 12. Let's go ahead and write what these numbers represent. Age of children. And now what we're going to do is we're going to go ahead and give this line plot a title. So we're going to go ahead and actually, let's do this. Let's just combine the soccer camp. rather than doing this 2 different times, because you'll get some practice on IXL doing the same skills. So let's call summer soccer camp. So near the top, you're going to write summer soccer camp. Now we're going to go ahead and put an X to represent each child that's signed up for summer soccer camp. Go ahead and I'm going to cross off so I don't miss anybody or duplicate the information. So we're going to start with Liam. Liam is 8. We're going to put 1 X to represent Liam. Penelope is 10. Let's put an X above 10. Ethan is 11. Abdul, 10. At any point in time, if I'm going too quickly, go ahead and pause the video. Logan is 11. Grace is 8. Sadie is 10. Darla is 12. Matthew is 11. Emma is 11. Darius is 8. Olivia is 11. Nora is 10. Ella is 8. Noah is 12. Hudson is 11. Lucy is 10. Wyatt is our first 9-year-old. Ivy is 10. Faith is 10. Tamako is 8. And Mason is 10. Kind of running into my picture there. Now what we're going to do is we're going to answer some questions. This already shows me a couple things. We mostly have we mostly have 10 and 11-year-olds. Only 1 9-year-old and not many 12-year-olds. I've removed the data and put in some questions that we are going to ask about this summer soccer camp. Sorry, I had to remove the title to get the questions in there. Number 1, write this on your whiteboard somewhere or answer in your head or out loud. How many more 11-year-olds than 8-year-olds played or signed up for summer soccer camp? Now what I need to do is to go ahead and figure out how many 11-year-olds. 1, 2, 3, 4, 5, 6. So 6 11-year-olds compared to 8-year-olds. 1, 2, 3, 4, 5. So 6 minus 5 would be what? 1. So there's 1 more 11-year-old than 8-year-old. The second question, how many players are 10 years or younger? Go ahead and count that up on your own. Well, 10 years or younger, you actually would include the 10-year-old. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There would be 14. How I figure that out is to take 1, 2, 3, 4, 5, 6, 7, 8. 8 10-year-olds plus 1 9-year-old plus 5 8-year-olds. Third question, how many 8-year-olds signed up for summer soccer camp? Go ahead and count the 8-year-olds. 1, 2, 3, 4, 5. And lastly, how many students are registered for summer soccer camp? In order to figure that one out, I would add together all of these. Sometimes it helps to actually write the number up above. So counting all of those, 1, 2, 8 of those, 1, 2, 3, 4, 5, 6, and 2. So if I add together 5 plus 1 is 6. 6 plus 8 is 14. 14 plus 6 is 20. And 20 plus 2 is 22. That was a much shorter lesson today, so you'll be doing some additional practice in your packet and on IXL today.